Questions 21 through 25 on the 2014 Grade 10 Cayley Math Contest. In the diagram, the shape consists of 7 identical cubes with edge length 1. Entire faces of the cube are attached to one another as shown. What is the distance between P and Q? Well, let's join P to Q and let's see what we can do. We can get a Pythagorean relationship with this triangle right there. And although it may not look it, this is going to be a right angle. I will start labeling this PQ, let's just call that R. So PQ squared will be PR squared plus QR squared. And we know that the length is 1 for each of those edges, so QR is going to be 3. So that's pretty straightforward. That's just going to be 9. But PR, that I don't know yet. So that I have to figure out independently. So PR squared, I can use this triangle to figure out where this is a right angle right here, like that. So PR squared, that's going to be 1 squared, and this side from here to here looks like 4. Plus 4 squared. So that's 1 plus 16, and therefore root 17 is equal to PR. And yeah, so PR squared is actually just 17, so I didn't really even need to make the root. All right, so PQ squared is 17 plus 9, which is 26, and therefore PQ is equal to root 26. And there you go. So number 21, the answer is B. A 5-digit positive integer is created using each of the odd digits 1, 3, 5, 7, 9 once, so that the thousandths digit is larger than the hundreds digit, the thousands digit is larger than the ten thousands digit, the tens digit is larger than the hundreds digit, and the tens digit is larger than the units digit. How many such 5-digit positive integers are there? Well, if that is represented as letters, say A, B, C, D, and E, the question essentially is just telling us the following, that B is greater than C and is also greater than A, and D is greater than C and is also greater than E. That's pretty much what all of this is telling us. So now it's just fiddling around with this, messing around with those numbers to try to get something that fits. So there's hopefully some strategy here, and I think that we can employ some strategy for A, B, C, D, and E. And I'll do a couple. So first and foremost, let's just concentrate on that, right? So B has to be at least 5 because it's greater than 2 numbers. So if it's greater than 2 numbers, it's got to be greater than 1 and 3. So 5 is sort of the starting point. So I can put the 1 and 3 here, or the 3 and 1 here. There's only 2 numbers remaining, 9 and 7. So obviously the 9 has to go here. So that's probably the easiest one to figure out. Okay. Well, I noticed if I'm going to go 9 and 7s, let's just follow that. Why don't I just go 9 and 5s? And then 9 and 3s, and then 9s and 1s. Let's see if that works. And when you try to follow this pattern, you get the following numbers. You get 7, 7 here, and you can alternate 1, 3, 3, 1. On the next two, again, you put the 7s, 7, 7, and then you alternate with 1, 5, and 5, 1. And then the last two, again, you can put 7, 7, and you alternate with 3, 5, 3, 5, 5, 3. So, perfect. How many did I get? I got 8, and 8 is one of the answer choices, but so is 16. And since 8 and 16 were right beside each other, it kind of made me think, maybe I shouldn't be so hasty here. And very quickly I realized that these guys can be just flipped to create 8 more. And when I say flip, what I'm really referring to is just writing them in the other direction. Like for example, this one 15397 can be written as 79351. You see what I mean? That's what I mean by flip. And each of those can be flipped like that. 79153 and so on. And when you do, you will find that they also satisfy this criteria. So let's just do it. 59371, 59173, 39571, 39175, and the last two 19573 and 19375. All right, so we got 8 here and we got another 8 here, so the total is 16. So number 22, the answer is C. 3 friends are in a park. Bob and Clarice are standing at the same spot, and Abe is standing 10 meters away. Bob chooses a random direction and walks in this direction until he is 10 meters from Clarice. What is the probability that Bob is closer to Abe than Clarice is to Abe? Well, initially, we have some scenario here where Bob and Clarice are here at this point, and 10 meters away is Abe. And then Bob will start to walk 10 meters in some direction. Now, we don't know where he's going. Maybe he's going here, maybe he's going there. But one thing is for sure, that he's going somewhere that would create a circle, right? Because he's always 10 meters away from where he originally was, which was with Clarice. So let's just say he's here. I don't know where he's going to be, but let's just say he's there. And let's draw in that circle. All right, perfect. So what I've done is I've said that he's walking 10 and he's going to end up there. So let's just label it 10. 10 there and 10 here. Now the thing is, he's going to be there, but he could be anywhere on this circle. He could be here, he could be there, and so on, right? He could be anywhere. I don't know where he's going to be. But they have given me a criteria that wherever he ends up, they want the distance from him to Abe, which I guess would be that distance, to be less than the distance from Clarice to Abe. Well, currently it doesn't seem to be the case at all. So let's just write that here. We want the distance from B to A, which is BA, to be less than the distance from C to A, which is Clarice to Abe. And C to A we know is 10, so basically we'll want the distance to be less than 10. Okay, so I don't think it's going to be here. It's probably going to be, I don't know, maybe here perhaps, where Bob is going to be. And if Bob is there, then his distance, if I draw a line, would be from there to there. All right. And then what I'm going to do is I'm going to connect C to B like that. So now, what I'm interested in is this angle here. Angle theta. And if I can figure out that angle, that's going to help me a lot. But before I do, I also want to point out that this identical situation could happen here. Bob could be here also. And therefore, that distance would be like this, from B to A. So theta can be there as well. So as long as Bob is in between that part of the circumference, we're good. As long as BA is less than 10. So how do I make sure that BA is less than 10? Well, looking at this graph, the distance from there to there is just the radius, so that's going to be 10. And the distance from here to here has got to be less than 10. So 10 is the sort of upper limit, right? And if it's less than 10, then he'll end up here. So this triangle helps me figure out that theta. Why? Because if you notice, it's equilateral. So that means all of these angles are 60, 60, 60, and 60. So that means this whole range is 120. As long as he is within this range, so it would be between there and there on the circumference, he will be in a position, let's just say here, where his distance to A will be less than 10. So I hope that makes sense. Well, what percentage of the circle is 120 degrees? Well, I divide by the total number of degrees, which is 360, and that just reduces to 1/3. So that is the probability of this question. So number 23, the answer is B. For each positive integer n, define s at n to be the smallest positive integer divisible by each of the positive integers 1, 2, 3 until n. For example, s at 5 is 60. How many positive integers n with n between 1 and 100 inclusive have s at n equal to s at n plus 4? First, let's explain this s at n a little bit more carefully. What is s at n really talking about? Well, really what it is trying to figure out the LCM, lowest common multiple of that number. And if it's a single number, well, that's easy. S at 1 is straightforward. But if it's two numbers, for example, s at 2 is basically saying find the LCM of 1 and 2. Well, that's pretty straightforward also. But what if you have 3? It's saying find the LCM of 1, 2, and 3. Okay, that's 6. And then s at 4. Now, this is the first time where we actually have to do a little bit of thinking, because 4 can be written as 2 times 2. So now the LCM will be 2 times 2 times 3, which is 12. Right? That's all this is, really. So what I'm going to do is write out not too many, but just a few, just to sort of get an idea. So 5, we've got to find the LCM of these numbers. Well, each of these must be written in their prime factorization to get a better understanding. And when you do that, the LCM will be 2 times 2 times 3 times 5. And that's 60. And that's the one they gave us in the question. How about s at 6? Well, now it's 1, 2, 3, 4, 5, 6. That's 2 times 2, that's 2 times 3. The LCM will be 2 times 2 times 3 times 5. And that is 60 again. So as you can see, sometimes it's the same. And then s at 7, again, that's going to be 420, because now I've got to add in 7, because it has to be looking at the first 7 numbers, and the LCM of those first 7 numbers is 420. So if you keep at this, I'll just do one more s at 8. That's 1, 2, 3, 4, 5, 6, 7, and 8. This is 2 times 2, this is 2 times 3, and this is 2 times 2 times 2. You now will get 840. So I hope you can clearly see that the LCM changes whenever we introduce a new prime factor. So for example, I really want to hammer this home here, otherwise the question won't make sense. We started off with 1, okay, pretty straightforward. Then we got to 2. We introduced here a new prime factor, that's why it went to 6. Here we introduced an additional prime factor, that's why it went to 12. Here we introduced an additional prime factor, it went to 60. Here there was no new or additional prime factor, that's why it remained at 60. Here we added 7 as the new prime factor, it went up to 420. Here we added an additional 2 as the new add-on prime factor, that's why the LCM went up to 840. So the LCM goes up every time you add a new or additional prime factor. So I really hope that makes sense, because that's the heart of the question here. You got to understand this. If you do, let's move forward. Keeping in mind what they want, which is they want to eventually figure out a situation where s at n is the same as s at n plus 4. How many of those are there between 1 and 100? All right. Well, they're making us work here. So what I'm going to do is write out all the numbers from 1 to 100, and I'll come back and talk to you about them. All right, so here we go with this masterpiece here. And the key to solving that is to recognize that that will be true only if there is no new or additional prime factors between those two numbers. So since that is so important, I'm going to write it at the bottom here so it's constantly there for you to see as the rule for this question. All right, so there we go. Now, the first thing, of course, is to look at the prime numbers, because if two prime numbers are side by side, or when they're not going to be side by side, but if they are within 4, then this is going to fall apart immediately. So let's circle the prime numbers. This is where your knowledge of the first prime numbers is going to be valuable. And for those of you who have not memorized them, I encourage you to memorize at least the ones in the first 100. So let's see if I can circle them accurately. 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and I think there's one more, 97. Okay, why was this important? Well, if you look at it, this rule pretty much is going to be, applied throughout the question. So I'm not going to keep repeating it over and over again. So I'll just call it rule. We'll just call it rule. This rule basically falls apart when you look at the fact that you've got two primes that are within 4. We've got to have a situation where we have two numbers that are not going to have any new or additional prime within 4, a range of 4. So, for example, something like this, right? We don't know that yet, but it looks like it, right? Between 75 and 74 and 78, that's a range of 4, and there's no prime in between them. So that's a candidate. It may fall apart for some other reason, but that is a candidate. So what I'm going to do on the side is write all the possible scenarios that do not have any of these primes in a range of 4. So, for example, we can easily do it from the end. It's easier at the end, right? So, for example, s at 92 could be equal to s at 96. Right? Because between 92 and 96, there's no prime in that 4 digit range. So it's a candidate. Now, I'm not guaranteeing that that's going to work, but it's possible. And similarly, s at 91 could be equal to s at 95. So what we will do is first just list all of these that from this list do not have any prime in a range of 4. So let me just list those really quick. S at 90 could equal s at 94. And then s at 89 could equal s at 93, and so on, right? So I'll fill in all the ones, and I'll come back and we'll discuss it. All right, so we got a whole bunch of candidates entirely based on this list with the prime numbers being circled. Okay, so far I have listed 18 right here. This is 18. Well, 18, if you look at the answer choices, is not one of the answer choices. The answer choices range from 9 to 13. So that's some progress that I'm in the range. That basically just means that of these 18, we have to start eliminating some. Okay, so this is the part of the question that becomes challenging. We have to start eliminating. All right, well, I want to do this in a way that you understand it, so I'll try to be slow here, but not too slow. 24 is 2 times 12. Now, have we introduced, look at the rule again down here, have we introduced any new or additional prime numbers when I went from 23 to 24? And the answer is no. What about 5? 25, it's 5 times 5. Have I introduced any new or additional prime factors? And the answer is yes. It's the first time where I've got 2 5s. Nowhere before there were there 2 5s. So this makes this list change, right? Because now when you take the LCM of, say, 25, it will need to have 2 5s in it. That rule comes into play. So that means that this guy is out, and so is this guy. Because if you take the LCM up until here, sure, it'll be something, but then when you take the LCM up until this, it will include another 5, because we have introduced an additional prime factor, namely 5. All right? So we have to do that for all of this. So it's a bit time consuming, actually quite challenging, I think, on a math contest, but here we go. All right, let's just keep going. Some of these are a little bit easier though, because remember, we're only dealing with prime numbers. So there's not that many prime numbers, right? Especially considering that we're only looking now at multiples of 2, like 5 times 5, 7 times 7, 9 times 9. You see what I mean? There's not that many of them. So let's look at from that perspective. If we have, say, 7 times 7, that's going to be right here. And again, it's the first time that we've introduced 2 7s. So the LCM up until here, whatever it is, will definitely be different when you take the LCM up until 49. So that makes these two fall apart. See what I'm saying? All right, great. Now let's look at this from any other perspective. Well, 11 times 11 is 121, so that's way outside the range, so we don't need to worry about that. And that's the only other prime number, right? Yeah. Okay, so I've taken care of the situation where there's 2 prime numbers multiplied together. Now let's look at a situation where we have 3. So something like 2 times 2 times 2, or 3 times 3 times 3, like that. Well, 2 times 2 times 2 we've already taken care of right here. There was nothing in here that is that early, so we don't need to worry about those. 3 times 3 times 3 is 27, and that is right here. But again, there's nothing here that we need to worry about. But the first time I think we need to start considering something is when you have a lot of 2's, and in particular 2 to the power of 5. So for example, this guy right here, this is a crucial one, because this is the first time where we introduce 2 times 2 times 2 times 2 times 2. It's the first time that you have a 5th 2, and that follows the rule. It is an additional prime factor. So that means that the LCM up until here will only have 4 of those 2's, but once you get to 32, you add that 5th one. So the LCM after that will have an additional 2. So that makes the rule apply, and therefore it makes this one fall apart. But here's I think, in my opinion, the hardest part of the question is this guy right here. That is, I think, the one that separates the people who get this right and the people who get this wrong. Does that fall apart, yes or no? And the answer is no, it's valid. It's perfectly valid, because up until 32, before 32, we only had 4 possible 2's. Once you get to 32, you get that 5th 2. And then after that, if we go up to 36, it's fine. All of these have those 5 2's as prime factors. So this is a perfectly valid relationship. All right. Now we have to see, are any of these other guys going to fall apart? using our prime factors. And again, I'm just going to stick to 2's because the other ones are not going to help in any way. 3 times 3 times 3 is 27, but 27 isn't important. If you multiply it by 3 again, it gets to 81, and 81 is not in this list. So I'm just going to stick to 2's. So now it's 2 to the power of 6, which is 64, this guy right here. And that is 2 times 2 times 2 times 2 times 2 times 2. It's the first time that we have a sixth 2. So if we were to take the LCM up until that point, it's only going to have 5 2's. But once you get to 64, you have to add an additional 2. So therefore, the LCM of that up until 64 will be different. So that means this falls apart and this falls apart. Those will no longer be true. And that's it. Everything else stays valid. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 that fit that criteria that S at n is equal to S at n plus 4. And therefore, the answer to this question number 24 is 11, which is choice C. Point P is on the y-axis and y-coordinate greater than 0 and less than 100. A circle is drawn through P, Q, 4, 4, and 0, 0. How many possible positions for P are there so that the radius of the circle is an integer? All right, let's draw a diagram and illustrate this. Well, here's such a circle. We'll label this point P. I'll just call it 0, small p, like that. We'll label this point, of course, the origin, which is 0, 0. And then somewhere approximately here, perhaps, will be our value of Q. And we will label the center of the circle somewhere here, and we'll call that C for center. So now let's proceed with this question. The first thing I'd like to do is look at the distance from O to P, which is right there, right? O to P. And I'd like to find the midpoint. So midpoint of OP. And that can easily be figured out. 0 plus 0 over 2, and then P plus 0 over 2. And that is, of course, 0 P over 2. So 0 P over 2 is obviously somewhere here. So 0 and P over 2. And now what I want to do is draw a perpendicular bisector. So a line that cuts OP in half, but a line that's perpendicular. So therefore, something known as the perpendicular bisector. And that line will obviously be something like that. So let's just draw it in a different color to show that it's going to be perpendicular and cut it in half. And let's just draw in a right angle to show that it's perpendicular. Now that line that I just drew in red, it passed through C, and it obviously has the equation y is equal to P over 2. It's a horizontal line. X can be anything, but the y coordinate of that line will always be P over 2. All right? So that's basically just the first part of this question. Now I'm going to do something very similar, but this time with OQ. So now I'm interested in this line right here between O and Q. So that one right there. And here we go. Same kind of thing. Midpoint of OQ. So we got 4 plus 0 over 2. And then 4 plus 0 over 2. And that, of course, is just 2, 2. So 2, 2 is somewhere here. Most likely, right? In the middle. And then, again, same thing. I want to have a perpendicular bisector. And that would be something like this. It's going to be something like that, where this is, of course, a right angle. And I'm interested really in the equation of that perpendicular bisector. Well, the equation shouldn't be that difficult to figure out. The slope of this line here, OQ, is really rise over run, which is 4 over 4 if you did it, and that's just 1. So the equation of this, since it's perpendicular, will be the negative reciprocal, which is -1. And now, since all lines have the form y equals mx plus b, I've got the slope, I've got 1 point on that line, so I can figure out that equation pretty easily. I can put in 2, -1, 2, and then calculate b, and when you do, you get b is equal to 4. So there you go. The equation is y is equal to -x plus 4. That being this line right there. Okay, so now to figure out c, all I have to do is figure out the intersection point of those two perpendicular bisectors. That was the whole point of doing all of this. Perhaps I would have mentioned it in the beginning, but I wanted to do this first because otherwise it wouldn't have been as, in terms of like making sense. So why are you doing this? And it's more obvious once you do it and show it. So now I'm interested in finding the coordinates for C. And C can be figured out pretty easily, equating these two. So basically, I have a situation where P over 2 is equal to minus x plus 4, or x is equal to 4 minus P over 2. So the coordinates of C, I'll write them here. The x coordinate is basically 4 minus P over 2, like that. And the y coordinate, interestingly, is P over 2. Why? Because it's on that line. And that line is y is equal to P over 2. So there we go. Now we got the coordinates for C in terms of P, but that's pretty decent. Okay, so now we move on to part 2 of the question. Now what I have to do is I have to figure out the radius of this circle. And the radius of the circle can be figured out by calculating the distance from the center to any of the points on the circle. But I'm going to use these 2 points, C and P. Or I can use I can use C and O, which O is right here, right? That's the origin. Or I can use C and Q. So it's up to you, really. Looking at this, I guess the simplest one in terms of algebra would be just C and O. That'd probably have the simplest calculations involved. So let's just use that. Radius is equal to OC, and OC, using the distance formula, would be 4 minus P over 2 minus 0, all squared, plus P over 2 minus 0, all squared, and then you take the square root. So this is going to be, multiplying this out, 16 minus 4P plus P squared over 4 plus P squared over 4 over on that side. And then collecting like terms, this is going to be just P squared over 2 minus 4P plus 16, like that. So if you take out a half, you get P squared minus 8P plus 32, like that. And at this point, what you can do is you can complete the square. If you complete the square, things will start to look really good here. And completing the square is not magic. I mean, a lot of you in grade 10 definitely know how to do this. So what you would do is you would take half of this and square it. So half of that is -4. If I square -4, I get 16. But then you have to immediately subtract 16. And don't forget that 32 in there. So like that. And then now that allows you to factor those 3 terms. So this becomes 1/2 P minus 4 squared. And then this part is 16. But then when you kick it out of the brackets, don't forget to multiply by a half. So to make it 8. So that's called completing the square, and I'm sure some of you know that. Most of you should know that. So now that it's in this form, what does this tell me? It tells me that when P is equal to 4, this will give me a value of R being equal to root 8. Right? So that basically means that when P is 4, we get the minimum possible value for R. Anytime P is greater than 4, of course, the value of R will just keep increasing. So that means that R is at least root 8. So it's greater than root 8. And root 8 is what? Approximately, 2.8? So that's sort of my minimum value for R. All right, that's a start. Now let's try to figure out what is the maximum value of R. And then we can figure out how many integers there are. Well, if you recall, P was anywhere between 1 and 99, right? It has to be greater than 0, but less than 100. It doesn't necessarily have to be an integer. I don't remember it saying that P had to be an integer. So let's look at what is the upper limit now. The upper limit, let's just say when P is 100, we'll get an idea of what R could be. P has to be less than 100, but if P was 100, what would R be? Well, just substitute that into here. P equals to 100. And when you do, you will get that R is going to be 67.94. All I did was put P equal to 100 into that equation and solve for R. That's how I got R equal to 67.94. All right. So combining, that means that R has to be obviously less than 67.94 and greater than this 2.8. So that means R, in terms of the integer values, because R has to be an integer, is anywhere between 3 and 67. Okay? So how many integers are there between 3 and 67? Well, 65. 65 values of R are possible. But the question is not asking how many possible values are there of R. They're asking how many possible values are there of P. Now you might say, okay, well, perhaps for each value of P, I get one value of R. Is it like that? If so, the answer would be 65 values of P. Well, what we need to do is look at the graph of this to get an understanding of the relationship between R and P. So here we go. This is a graph of this function basically. And you don't necessarily need to draw it. I just wanted to include it to further explain this question. As you can see, and this will be the axis for P, and this axis is R. And P is between, as you can see, 0 and 100, and R, well, it keeps on going. When you look at this graph, hopefully you will see the following relationship, that if I made a little table, let's say R and P, and kept going like that, that when P is 0, R will be 4. Now P has got to be greater than 0, so that value of R doesn't count. But when you get to a certain P1, you will get R being 3. And then when you get to a certain value of P, namely 4, you get the root 8, which is equal to 2.8. And that is, of course, the minimum value, as you can clearly see on that graph. But once you start going forward this way with values of P, the values of R start climbing back up again. So whatever it is, some value of P will give me 3, and then some value of P will give me 4, and then so on and so forth, dot, dot, dot. Eventually, I'll get to some value of P, I don't even know what number we're up to now, let's just call it Pn, will give me the highest value of R, which is 67. So I'll put that in here, 67. So this is a understanding of how R and P work. You will get a whole bunch of values of p that correspond to integer values of r between 3 and 67, and that's 65 values of p. But if you look at this part of the graph, you'll notice that there's one additional, and that's this one right here. The 4 for p gives me root 8, which is not an integer value for r. The 0 for p cannot be used because p is greater than 0. But the value of 3 as an integer is valid for some value of p, and that value of p has got to be used as well. So that gives me my 66th value of p. So in total, there are 66 values of p that will give you integer values for r. So the answer to this challenging question is 66, not 65, and that would be choice C for number 25.